Okay, so we are given f prime, and we are given 1 point that at x equals -3, our y value is 7/3. And what we're going to do is we are going to estimate f of -3.1 given this information. So the easiest way to estimate another point that's close to a given point is to use a tangent line. So y is equal to m times x minus x1 plus y1. And then x1 is going to be -3, and y1 is going to be 7/3. But m is found by f prime of x1, which is -3. So we're going to use our f prime, and we're going to plug in -3 and see what happens. So that's ln of the absolute value of -5 divided by 3, which is ln of 5 divided by 3. And I'm just going to leave that for now. So then my equation of the line tangent will be y equals ln of 5/3. That's my slope. X plus 3 minus -3, so plus 3, plus 7/3. Okay, so to estimate what happens at -3.1, let's plug in -3.1. So that would be -3.1, plus 3, plus 7/3, which is ln of 5 over 3 times -0.1 plus 7/3. Okay, I'm going to have to plug this into my calculator. When I do that, I get 2.279685. Okay, so that's about 2.280. And yes, the 0 at the end counts as your third decimal place, so make sure you include it. So that's my estimate for f of -3.1 using the tangent line at y equals -3. Okay, now the next part of this, I'm going to find f double prime of x. And I actually don't need chain rule or quotient rule or anything special because I can just pull out the 1/3. And then the derivative of ln of x minus 2 is 1 over x minus 2. But we are going to keep the absolute value symbols, and that's because, remember, we are allowed to plug in negative numbers. If you think about the graph, we are going to have, like, you can't plug in x equals 2, but you can plug in -1, for example. So -1 would be -1 minus 2 is -3, and then that would become ln of +3 instead of -3. So what that does is it kind of reflects, like if you were to graph this, it's going to be shifted over 2, and then this is what the graph of ln of x minus 2 would look like. And then because it's at the absolute value is like these points will also exist on the other side. And that should, I'm sorry, it's not a very good graph, but like it's going to reflect over that asymptote of x equals 2 because I have the absolute value, which allows me to plug in numbers that are negative. So the derivative of ln is just like 1 over that thing. So that is going to include an absolute value in this case. And then is the estimate an over or an underestimate for the actual value of f of -3.1? So all you need to do is figure out if your graph is concave up or concave down. So if you think about like concave up, tangent lines provide underestimates. If your graph is concave down, tangent lines provide overestimates. So we just need to figure out, is my graph at -3 concave up or concave down? Okay, so that is because that was where the tangent line was touching the function, was at -3. So I'm not plugging in -3.1. We're using x equals -3 to consider the value of -3.1. So that is going to be 1/3 times 1 over 5. Okay, I don't care what that actual number is. All I care about is it positive or negative? And it is a positive number. So I would say because f double prime is greater than 0, f is concave up. So the tangent line provides n, and again, just graph a concave up function. You don't actually need to know what the function looks like. You just need to know that this function is concave up at -3, provides an underestimate. Okay. So your justification should look something like this. It should include your second derivative, the fact that f is concave up, so that means the tangent line provides an underestimate.